Now we will discuss a question. A causal discrete LTI system is given to us. Yn 3 by 4 1 3 by 4 yn minus 1 1 by 8 yn minus 2 xn. Both are input and outputs. Determine transfer function, impulse response and step response. For solution of this question, taking Z transform in both direction. X of Z 1 minus 3 by 4 Z inverse plus 1 by 8 square YZ XZ HZ YZ upon XZ equals to 1 upon 1 minus 3 by 4 Z inverse. By taking partial fraction, this is the first question answer, transfer function of the system. By taking partial fraction, we can calculate impulse response. For partial fraction, we have to solve for z square, z minus, and factorize in this way. For partial fraction, we factorize this in this way and calculate a and b. We find a equals to 2, b equals to minus 1. Hz is finally comes to us is in the question. ROC is given to us, causal ROC is given to us is this. We directly write expression for inverse Z transform in this way, minus 1 by 4 NUN. This is our complete answer for impulse. Now we want to calculate, after calculating impulse response, now we want to calculate step response. We have transfer function with us. Transfer function of the system is YZ upon XZ, and transfer function is Z square for YZ. Transfer function is given to us for YZ Z square Z minus half Z minus 1 by 4 XZ, where XN is unit step, XZ is Z upon Z minus 1. We place value of XZ here, YZ equals to, we get 2 Z minus 1 Z minus half Z minus 1 by 4 Z is greater than 1. By partial fraction, we get the result in this way, 8 by 3 Z upon Z minus 1. By taking partial fraction a, b, c, 3 factor, first Z by Z and then solve it. 2 upon Z plus 1 by 3 Z upon Z minus 1 by 4. Z is greater than 1, ROC. Then we directly write expression for this. Yn equals to 3 by 8 to 1 by 2 n plus 1 by 3, and un. This is the direct expression for step response. Step response, when step is applied, output is in term of discrete sequence. Now we will discuss a small topic, FIR filter, introduction to FIR filter and IR filter, which is not related to Z also, but filter. This filter is maybe asked. Some definition should be clear. What is filter? This is digital type of filter. First, digital filter. FIR, finite impulse response. Infinite impulse response. Impulse response. If finite impulse response, FIR. If infinite impulse response, IIR. Definition of FIR is yn equals to summation k equals to 0 to m bk x n minus k. This is the basic definition of FIR, finite impulse response system. Means delaying the input sequence, input signal create a finite impulse response. It means a copy of the input signal combined with current input signal to generate output. It is called FIR, finite impulse response. I repeat, delaying some input amount is delayed. Only input is delayed, not output. We are delaying some input and mix with current input, produce the result is called finite impulse response. It is also called as feed forward filter. If filter is combination of, for example, filter is consist of yn equals to x n plus x n minus 3 x n minus 10 plus x n minus 50, previous value of input only, it will produce FIR. FIR filter is stable filter as compared to IIR filter, but less effective. For IIR filter, it have finite response. Response is limited within the band. Finite response. Number of sample in the output is finite. If we put impulse as an input, del n as an input, we get finite response. Del n plus del n minus 3 del n minus 10 del n minus 50. Finite impulse response located at 0 location, 3 location, 10 location and 50 location. Finite response. In the case of IIR filter, there is infinite impulse response. Basic expression for IIR is k up to m bk x n minus k. First section is similar to FIR, but difference is feedback amount, feedback of output value, previous output value up to mn ak y n minus k, previous value. This is commonly known as IIR, infinite impulse response. It is not surely stable, may be stable because stability is disturbed due to feedback component. Output is feedback into, it is called feedback filter. Feed forward filter is IR, feedback filter is Feedback filter is IR. Feed forward is FIR. FIR filter. We are delaying output signal and input signal and combined with current value to generate output. It is known as IIR filter. Such type of information is required to solve the question. Example, yn equals to yn minus 2 equals to xn minus 2 plus xn minus 3. This is IIR filter because feedback element is there and also input delay in input amount is also there. Both generate IIR filter. I took two more example to clear FIR and IIR filter. Yn equals to xn 2xn minus 2 plus xn minus 3. Yn equals to yn plus 2yn minus 1 xn plus xn minus 1. Find out which type of filter, FIR or IIR. To find out the filter type, first apply impulse as an input. As we apply impulse as an input, we find this result. Hn can be represented in this way: at 0 location 1, at 1 location nothing, at 2 location minus 2, at 3 location 1 with arrow. This is impulse response. Impulse response of FIR filter have finite sample, 4 samples, means it is FIR filter. If impulse sample have infinite value, means it is IIR filter. In second case, by viewing we can say there is feedback element, means it is infinite response filter, but we put some value as a input impulse, then we check it is IIR filter or FIR filter. Just we are putting twice h negative n minus 1 del n plus del n minus 1. Step by step I putting some values. 0. Once I put 0, minus 2 h minus 1 del 0 del minus 1. Del 0 is 1, this term h minus 1 because Hn is causal system, physically realizable system, it is 0. Minus 1 and less than 0. Minus 1 is 0, minus 2 is also 0. If it is 0, then it might be some value. 0, 1 and 0. H0 is 1. In this way we calculate other value. H1 also. H1 is minus 2h0 plus impulse 0. We got minus 2 into 1 plus 1 equals to minus 1. H2, by putting value we get 2. H3 we get minus 2 square. H4 we get plus 2 cube. Hn we get minus n 2 power minus n minus 1. Hn is this. Hn has infinite terms, so it is IIR filter.